So fine. What we have studied so far. Okay, fine. Now we have studied in the last lecture that how to subtract two numbers using 2's complement, or in other word, in case of the r's complement. So we have done an example. Suppose x is given by 101010 and y is 10000011. And suppose we have to perform the operation either x minus y or y minus x using 2's complement. So let us take a quick revision of this. Then we'll consider another example so that the topic may be sorted out. So what the algorithm says, whatever is the operation, either x minus y or y minus x, you have to do whatever is number is in the minus. There in case of the first, it is x minus y. So what we do, we take 2's complement of the y, and in another case of the example b, that is y minus x, we take 2's complement of the x. Means whatever number is in the negative, we take that 2's complement of that particular number and add it to the positive number. Now consider the case of the first, that is a. Now we have to perform x minus y. So what we do here is x. So we have to subtract y from the x. So we have to take 2's complement of the y. So what we do here, we take 2's complement of the y, and the 2's complement of y is comes to be 0 1 1 1 1 0 1. And this 2's complement is taken, first we take 1's complement and then add 1 to the 1's complement, and 1's complement is nothing but we are just changing the bits. 0 is replaced by 1 and 1 is replaced by 0. So we take 2's complement of y, then add it to x, and it results, it is 0 sorry 1 0 0 1 0 0 0. Now what we do, we have to check the number of bits, that the number of bits in x and y must be equal and the sum should be of the same number. So here 1 2 3 4 5 6 7, x is of 7 bit, y is of again 1 2 3 4 5 6 7, y is of 7 bit. So our sum should be of 7 bit. 1 2 3 4 5 6 7 8 8, that means there is a carry. The x and y both are of n bit, then the sum should be of m bit. Now in this case, when there is a carry, what we do, we just discard the carry. This carry will be discarded and the final answer will be x minus y equals to 0 0 1 0 0 0 1. Is that clear?
Yes, sir.
Okay, now
Yes.
take the other example when we have to perform y minus x. Now in this case, what we do, we have to take 2's complement of the x, because x is to be subtracted from the y. So y is as it is. Now what we do, we take 2's complement of x. Now the 2's complement of x, again the process is same. First take 1's complement of x, and the 1's complement of x, if I start from here, it will be 1 is replaced by 0 and 0 is replaced by 1. So it will be 0 1 0 1 0 1 1. Then we add 1 to the 1's complement. Now it results 2's complement, and that comes to be 0 1 0 1 1 0 0. Now both x and y are of the 7 bits, then sum should be of 7 bit. So we add it simply. So it is 1 plus 0 is 1, 1 plus 0 is 1, again 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1. So here in this case, we have no carry. That is, if x and y both are of n bit, then the sum is again of n bit. That means there is no carry. In this case, when there is no carry, what we do, we again take 2's complement of the sum and put negative sign, because in this case, when there is no carry, that means x is greater than y. So in initial condition, we need not to worry whatever is whose number, which number is greater or which number is less. We just have to take 2's complement of the negative number added to the positive number. If there is carry, then discard carry. If there is no carry, then again take 2's complement of the sum. Though here I have taken the 2's complement of the sum because there is no end carry. So then y minus x is negative of 2's complement of this particular number. We have to take 2's complement and we have to put negative sign in before. So the number becomes 0 1 1 0 0 1 0 0 0 1, and that was true in the last case. Here the number was positive 0 0 1 0 0 0 1, because in this case x is greater than y, then the number is positive, and in this case y is less than x or x is greater than y, so number will be negative. Means 5 minus 3 or 3 minus 5, the magnitude will be 2, but the in the 5 minus 3 it will be positive. In case of 3 minus 5 it will be negative minus 2. Now let us take another example, and I suppose that all of you solve this particular number, solve this question in your notebook. Now suppose given we have x equals to 16 and y equals to 10, both numbers are given in decimal. Now perform the subtraction x minus y and y minus x using 2's complement. So I suppose I'll explain, or I'll dictate step by step, and you solve this question in your notebook. So first of all, what we have to do, we have to convert x and y, that is 16 and 10, into binary number. So all of you please convert these number into the binary. Convert 16 into binary, and the process is divide 16 by 2. Whatever is the remainder, that is your first coefficient. Then again divide the 8 by 2, it will come 4, remainder is 0. Again 4 is divided by 2, remainder is 0. 2 is the answer. Then again 2 is divided by 2, that is 1, 0 is the remainder. Again 2 is divided by 1 is divided by 2, 0, and the remainder is 1. So the coefficients comes to be 1 0 0 0 0. That will be your 16. And the same process will be done with the for y. Y equals to 10, divide 10 by 2, 5, and the first coefficient, that is remainder, is 0. Then again divide 5 by 2, that is 2, remainder is 1. Again 2 is divided by 2, 1, remainder is 0. Then again 1 is divided by 2, it is 1. So in this manner, if I solve this, x comes to be 1 0 0 0 0. When you solve this, when you convert 10 into binary, then the coefficient will be 1 0 1 0. So what I have done, I have just equals the number of digits. Oh, sorry, this is 10 is in, this is wrongly written, 10 is in decimal. So what we do, we just make equal the number of bits. Here the bits are 1 2 3 4 5. So here 1 2 3 4. So I have put it a 0 before 1. Is that clear? That you can convert this now?
Yes, sir.
Sir,
Okay, fine. Now the next step is we have to perform x minus y. So what will you do? You will take 2's complement of y. So how it is done? you just take 1's complement of y. So 1's complement of y is nothing but 1 is replaced by 0 and 0 is replaced by 1. So just do it. So I, in my opinion, it should be when I take 1's complement of y, it should be 1 0 1 0 1. Then add 1 to the 1's complement, it will result 2's complement. Is that fine? 1's complement of y is 1 0 1 0 1. I have added 1. Then it results 2's complement is 1 0 1 1 0. Are you able to calculate?
Yes, sir.
Okay, fine. Now what we do, we just now 2's complement of y has been obtained. We have to add x to the y. So I just add x, just put the x and add it. So when we add, it is 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1, 2 in decimal, then 2 is represented by 1 0. So 0 will be here and 1 will be your carry. So if I put here, then the sum will be like 0 plus 0 0, 1 plus 0 1, 1 plus 0 1, 0 plus 0 0, and 1 plus 1 is 1 0. So here again I'll have to check the number of bits. Here the number of bits are 5, here the number of bits are 6. So when we are doing this particular subtraction using 2's complement, what we do, when there is a carry, then we have to discard the carry and the final answer will be x minus y is 0 0 1 1 0. That is in decimal binary, and in decimal it is 16 minus 10 equals to 6. So 110 is nothing but that is decimal 6. Is that clear?
जी सर.
Okay, fine.
Yes, sir.
तो next step पे करते हैं. Now again in the next example we have to perform y minus x. So we'll take again in the same manner. So we have to perform y minus x. So what we have to do, first x and y both should be converted into binary number. So 16 is 1 0 0 0 0. 10 is 0 1 0 1 0. Now first of all, whenever either it is given directly, it may be given directly in the binary form or it may be given in any of the binary hexadecimal, and it will be specific that which complement you have to use. So whatever complement you have to use, either 2's complement, 10's complement, 8's complement, 16's complement, so you have to convert this number into particular that number system. So here we have to convert using 2's complement. So I have converted 16 into binary and 10 into binary, and make sure in case of both x and y, the number of digits or number of bits must be equal. So if there is any unequal number, so you have to put at the MSB side. So now we have to perform y minus x. So what we have to do, we have to take 2's complement of x. So how to calculate 2's complement? First, calculate 1's complement of x. So here is x, and 1's complement can directly be taken by replace 0 by 1 and 1 by 0. So here it comes to be 0 1 1 1 1 like this. Then add plus 1, you will get 2's complement of x. So here is 1's complement x is 0 1 1 1 1. I have added 1. So again, how it is added? 1 plus 1 is 0, carry 1, because 1 plus 1 is 2. So 2 is represented by 1 0. This 1 0 here. So 0 is here, 1 is carried carry forwarded. Then 1 plus 1 again 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. So again we get 1 0 0 0 0. So you may say that x 16 in itself and 2's complement of 16 both are same. So the next step is add x to the 2's complement of y. So y is here. Sorry, this is it should be it is wrongly written. It should be x. So add y. When we add y to the 2's complement of x, then it comes to be 0. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1, and 1 plus 0 is 1. Just add it, and here is your sum. So now what we have to check? We have to check is there is any carry or no carry. So I calculate, I count the number of bits in x and y. So it is 1, 2, 3, 4, 5. So it should be 1, 2, 3, 4, 5. Means there is no carry. So in this case, no carry is generated. So what we do? We have to take again 2's complement of the sum, and we have to put a negative sign before that. So 2's complement of 1 can be calculated. First take 1's complement of sum, then add 1 to the 1's complement. It will be the 2's complement. So 1's complement of sum is, I have just replaced 0 by 1 and 1 by 0. It is 0, 0, 1, 0, 1. So 1's complement nothing, but we have to complement the number. 1 is replaced by 0, 0 is replaced by 1, and then I have added a 1 to the 1's complement. It will result in the 2's complement. The 1 plus 1 is 0, 1 is carry forward, 1 plus 0 is 1, here is 1, 0, 0. So the final answer y minus x is, though we have to put a negative sign, minus 0, 0, 1, 1, 0. That is 10 minus 16 is minus 6. This magnitude is 6, and we have to put a negative sign. Is that clear?
Yes, sir.
Yes, sir.
Okay, fine. So now we have to move to the another topic, that the same process to perform subtraction can be done with the diminished complement, that is r minus 1's complement. Let us take a quick look on the algorithm. Then when we solve the question, it will be much easy, because in some cases the algorithm is tough to understand, because it is totally mathematical manipulation. When we do it ourselves, then it is very easy. So when subtraction with diminished radix complement. So let us first discuss the algorithm. The subtraction of two n-digit unsigned number. So unsigned I'm saying because I have considered that all number are positive. We have not considered that any number is negative. So what we have to do, we are considering the unsigned numbers 0 to 9, like this. Means on the negative axis there is no number. We'll discuss in the next topic what the unsigned numbers are. So we have a given base r. We have to subtract two n-digit number. Again, the line is very much clear that in both m and n, number of digits should be same. If the number is different, so what we do, we add the number of zeros which are less in the any of the number. Now add the minuend, that is m, to the r minus 1's complement of the subtrahend. So what in that case, in case of r's complement, we have taken r's complement of negative number. In this case, we have to take r minus 1's complement. So in case of, that is, if it's decimal number, we have to take 9's complement of n. If it is a binary number, we have to take 1's complement, because r minus 1, that is diminished complement. We have to take 1's complement of the n. So just forget it about whatever this calculation. You have to follow the algorithm. If you have to perform m minus n, take r minus 1's complement of n. That's it. In the next step, if m is greater than n, the process will be same. The sum will produce and carry. Sum will produce a carry, and which can be discarded to get result m minus n by plus 1. Means if there is a carry, we have to add that carry to the sum, and the final result will be your m plus n. In the case of 2's complement, we were just discarding the end carry. In this case, we have to add that carry to the sum, and the final sum adding after 1 will be your final result. Now, if m is greater than m is less than m, the sum will not generate a carry. Same was true in case of 2's complement. So what we do to obtain the answer in familiar form, take r minus 1's complement of the sum and place negative sign in front of the result. So what is the difference between 2r's complement or r minus 1's complement? First step is same. We have to calculate r's complement or r minus 1's complement of minus n, that is of n. We have to add it to m. If there is a carry, in case of r's complement, we discard carry. In case of r minus 1's complement, we add that carry to the sum, and final is your result. If there is no carry, in both cases, either r's complement or r minus 1's complement, we again take the r's or r minus 1's complement of the difference, then we put a negative sign. That's it. And that will be much easier to do with the help of an example. Suppose given two binary numbers, same numbers I am taking again, x is 1 0 1 0 1 0 0 and y is 1 0 0 0 0 1 1. So here the number of digits are same, 4 7 digits number, both n and y are 7-bit number. So we have to perform x minus y and y minus x using 1's complement. So we'll go step by step. So when it is the first case, part A, when we have to perform x minus y. So what first we do? We take 1's complement of y and add it to the x. So all of you take 1's complement of y, then 1's complement of y is nothing but just replace 0 by 1 and 1 by 0. That's it. So do it yourself. So 1's complement of y will be 0 1 1 1 1 0 0. Here is your x. Here is your 1's complement of y. Is that correct?
Yes, sir.
Okay, fine. Add both numbers. So I add 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 1, 2. 2 is represented by 1 0. The 0 is here. 1 is carry forward. 1 plus 1 again is 0. Carry forward. So 1 plus 1 plus 1, that is 3. 3 is represented by 1 1. So 1 is the sum. Carries 1 is carry forward. 1 plus 1 is 0. 1 is carry forward. 1 plus 1 is 1 0. So here the sum has 8 digits or 8 bits. So what we have to do, we have to remove this end carry and just have to add it to the sum. So here comes end around carry is added to the 1 and the result is, sorry, 1 plus 0 is 1, then 0 0 0 1 0 0. Again it is 1 1 0 0 1 0 0 0 1. So that's your final answer, x minus y, which was in the case of previous example when we are using 2's complement. But in that case we have just discarded the carry. In this case we have to add carry to the result. Is that clear? Then we move to the
Yes.
next slide. Okay, fine. Now we have to perform y minus x. So what you have to do, take 1's complement of x. In this case, take 1's complement of x and add it to y. तो 1's complement हो जाएगा यहाँ पे, you have to just replace 0 by 1 and 1 by 0. So 1's complement of x should be 0 1 0 1 0 1 1. Correct?
Yes, sir.
Okay. So add it to y. So here is your y. Here is your 1's complement of x. And we just add x and y. Sorry, y and 1's complement of x. So here it comes 1 plus 1 is 0, carry 1. 1 plus 1 plus 1, 3. 1, carry 1. 1 plus 0 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. So here the sum is also of 7 bits. That means no carry. When there is no carry, we again take 1's complement of the sum and put a negative sign before. So the 1's complement of the sum will be 0, 0, 1, 0, 0, 0, 1 and put negative sign. You can see that in both cases either x minus y or y minus x. The magnitude is same, only the difference is of sign. In the first case, as x is greater than y, then the answer is positive. In the second case, as y is less than x, then the answer is negative, but the magnitude is constant or same. We take another example. Suppose x is 16 and y is 10. Perform x minus y and y minus x using 1's complement. So in the first case, when we are performing x minus y, so what we do, first of all, we have to convert both x and y in the binary form. Then it is your binary form. X is 16, 1 0 0 0 0, and y is 10. It is 0 1 0 1 0. So what we do, we have to perform x minus y. So we have to take 1's complement of y. That is 1's complement of y. We need not to do anything. We just have to replace 1 by 0 and 0 by 1. Fine. Then add x. One plus 0 1, 0 plus 0 0, 1 plus 0 1, 0 plus 0 0, 1 plus 1 1 0. There is a carry. So what we do, we just remove this carry from here and add it to the result. Then 1 plus 1 is 0. 1 is carry forward. It is 1 plus 0 1. Here is 1 0 and 0. So when there is a carry, we have to add that carry to the sum, and the answer is 0 0 1 1 0. That is 6. 16 minus 10 is 6. Now we have to again, in the next example, we have to perform y minus x. So again, x is 16. We converted it to binary. Y is 10. We have converted into binary. So here what we have to do, we have to take 1's complement of x. So the 1's complement of x is 0 1 1 1 1. Add it to y. Y is it? Just add both numbers. Here is your sum. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 0, carries 1, 1 plus 1 is 0, carries 1, 1 plus 1 plus 1, 3, sum is 1, carries 1, 1 plus 0 is 1. So here we can see that there is no carry. So what we have to do when there is no carry, take 1's complement, take 1's complement of the sum, no carry. The 1's complement is replace zeros by 1's and 1's by zeros. So 1's complement of sum is 0 0 1 1 0. And what we do, we put a negative sign, and the final answer will be y minus x is minus 0 0 1 1 0 base 2, or in case of decimal number it is 10 minus 16 equals to minus 6. So in both cases, either we are performing x minus y or y minus x, answer is 6, depending upon either it is 16 minus 10 or 10 minus 6. Is that clear?
Yes, sir.
Yes, sir.
So I think